welcome to this week's Great River Rapport workshop. We are here at the St. Lawrence River Institute, joined with water rangers. We will be conducting some water sampling and looking at how to conduct citizen science, look at water quality, and how to put your water quality tests online and on the Water Rangers website. So we are joined with water rangers, as well as a few participants who are here live for the live demonstration of this workshop. Today we will be running through a series of different tests, and I'll actually let I'll pass it over to Laura, who will be able to explain a little bit more in detail what we will be doing today. So yeah, thanks.
Hi everyone online. As Yannick said, I'm Laura, and I'll be doing a demo today of the different components that are in the Water Rangers test kits. If you want more information, you can always go on our website, waterrangers.ca. So we do have some in-person participants, so I'll be showing them how to do everything and also turning to the camera to make sure that you can see everything. We'll be doing some tests at the tables here, then we'll do a Q&A online, and then those of us that are in person are going to go and do some more tests by the water. So if you have any questions, just keep those in mind, and you can ask some questions during Q&A time. And in person, if you have any questions, just like raise your hand while I'm presenting, and I'm happy to answer any questions as we go along. Sounds good? Okay. So yeah, Laura, we've already made introductions. I'm so happy to be here. I just drove in from Montreal today to be here with you, and it's such a beautiful campus, and it's such a beautiful day for water testing. So as you already know, we're going to be looking at Water Rangers test kits. So a little bit more about Water Rangers. So we're a nonprofit that's mostly based in Ontario, and it was founded in 2015 by our now executive director, Kat, because she used to go testing Lake McLaughlin, which is just on the Quebec side close to Ottawa, with her dad every summer. And he was part of a lake association, and he would take some samples and he would send them to the lab, but he didn't have a science background, so he'd get the results back and his lake association would make a report, but it was really hard for people to understand what those results meant, and they also didn't have a good way of sharing that information with everyone. So she decided to create an online platform with open data. So all of the data that we collect today, you can go and put it online. So you'll have little notepads where you can take notes. And if you want to, you can upload it to the website. We also have an app for you that are out there looking online. So you can download the app and put in all of that data on there. You don't necessarily need to be using our test kits to put data online. So if you guys are doing a lab with your classes and you have some data for a water body that you want to put on there, you could just use the platform to do that as well, and that's totally fine. It's free to use. But we did realize that a lot of people also wanted some tools to be able to go and test the water, and that's why we developed these test kits that are super easy to use. And everything that we're measuring today, you're going to get the results right away, so they don't need to be analyzed in a lab or anything. And you also have little guides on the table that are going to explain everything super simply to you, so that you understand what your results mean right away. Does that sound good for everyone? Yeah? Okay. So we're going to start. I'm going to show you things right away. So I have my little tools here, so I'll be running back and forth. So the first thing you want to do usually when you go test is you're going to have a thermometer, and this one is an air thermometer. So usually we go hang it in a tree. I don't know if one of you wants to go hang a thermometer in the tree over there behind you, and we're going to be able to go get the air temperature at the end of our tests. So usually it has to be about 1.5 meters from the ground and in the shade. Yeah, that's perfect. You can just hang it in there. I will admit I always forget my thermometer in the tree, and then I go home and I have to go back and get it. So somebody remind me that thermometer is there at the end, please, so we don't forget it. So once that's done, you will find this selfie stick, which we've repurposed as a reacher stick. Oops. Doesn't usually do that. So this reacher stick is going to help you get your water sample without getting all wet. So Yannick and I have each gotten buckets of water from the 2 access points by the river over there. So I'm just going to show you how you'd use this. So you just put it on the cup like this, and you'd be able to go and get your sample easily without getting wet. So I'm going to go get a sample, and then I'll invite you guys to go take a sample from either bucket, whichever one you want. But remember which one you took so that we can compare results after. So I'm just going to go first. So I'm going to rinse my cup 3 times to make sure that it's really clean. And then you want to take your sample from the bottom of the bucket. So we usually say about at least 15 centimeters under the water. You want to take your sample because the top of the water is going to be a little bit different because of mixing and sunlight and everything. So you want to go a little bit deeper. So I'm just going to go take mine. So I rinse it. 1, 2, 3, and I go to the bottom of the bucket. And I'm going to have my sample here. So I will invite you guys to do the same now. Yeah, some of them have caps on. That's fine. You can still use. You don't really need your reacher stick right now. If you don't mind getting wet, you can just put your hand in there. It's up to you. Actually, I'm going to grab a few things. That's
Three
perfect.
times and just
Yeah, rinse it 3 times, take your sample, and yep. I see you've discovered how to use your reacher stick to make it, yeah, that's perfect. It's gonna stay in place. So once all the teams have a water sample, you're going to want to grab your conductivity meter. When we're talking about conductivity, does somebody know what we're measuring? Anyone want to answer?
The ions?
Yeah, the ions, right? So it's the electrical conductivity that's in there. So there's going to be little electrodes at the bottom, and it's going to send a tiny little current in the water, and we're going to measure the conductivity in microsiemens per centimeter. And this is also going to give you the water temperature. So it's super easy to use. You want to press the first button once to turn it on. Hopefully mine turned on, yeah. Some of yours have caps. If yours here looks covered at the bottom, then you have a cap that you have to pull off. I think everyone's done it. Everything's good. And then you just dip it in the water. And you're going to wait until it stabilizes. You can just completely dunk it in there and, let go of it and just wait. I do need to turn it around to be able to see. So, do people remember which bucket they took it from? So who took it from the bucket that's closest to me, their sample? Okay, and what's your measurement?
278 for conductivity and 20.3 for temperature.
Perfect. What about you?
it's 282 for electronegativity
Okay,
and 20.4 for the temperature.
perfect. So similar results. And what about you? You took the other bucket? 351. Okay, so that's quite a difference. So I took the first bucket, so I'm at 285, which is similar to the other ones, and you have 351. So we see that just from taking samples that are literally just a few meters away from each other, we're going to have different results. Any ideas what could impact conductivity, what might change the numbers that we get? Yeah, so that's one of them. So that's everything that's floating in the water. Do you have something?
Like the erosion and sediment runoff.
Yeah, and what were you saying, sir? The temperature? Yeah, so the temperature, because we're measuring specific conductivity, will have an impact. And like you were saying, erosion, yeah. So that's a lot of it. It's a lot of the sediments that are in the water. So it could be that one place has a different bedrock a little bit than the other one, and that's why we're getting different results. I thought mine would be very high because when I went to take my sample, there was quite a bit of sand in there and everything floating. So I thought that my sample would have a higher conductivity, which I guess it did, right? Mine was the left one, so that might have been on me. I might have shook the ground a little bit when I took my bucket. Okay, so perfect. If you guys want to write your conductivity for fun on your little notepads, you can. And to turn it off, we're just going to press the first button quickly again. Okay, so another thing we want to look at when we're taking water samples is the context. So we want to look at the weather. What's the weather like today? What was the weather like yesterday? So I wasn't here yesterday because I drove in from Montreal, but maybe somebody can tell me what the weather was like yesterday around here. Same. So yeah, humid, a little bit cloudy, but mostly a very nice day in the mid-20s. That sounds about right. Okay. Any ideas how the weather could impact the water quality?
If it's raining, pH can be different.
Yeah, the pH can be different, and also the temperature. That's very true. And somebody did mention turbidity before. So clarity and turbidity are connected, and so is conductivity. So if there's a really big rain, there can be those sediments and erosion that go into the water. There could be more mixing, and that could really affect what we're measuring. So if you go test a water body regularly, and then all of a sudden you see that there's a strange spike in something that you're measuring, then make sure to look at the weather from the previous 48 hours, because that could explain some of the differences. So the next thing we're going to do is use our little test strips to be able to measure chlorine, pH, alkalinity, and hardness. So somebody mentioned before that they look like aquarium test strips, but these are actually pool test strips, but we've done quite a few tests and these were the most accurate, and that's why you'll see that the first thing on there that it measures is chlorine. And everyone's like, oh, like we shouldn't have to measure chlorine, it should be found in natural water bodies. But a lot of the times in urban settings, you're going to find some chlorine. My sister used to live in Etobicoke, close to Toronto, and there was a little stream that ran behind her house. And I assume a lot of people must have emptied their pools there, because whenever she did water quality measurements, she would always get the measure of 4, which is ideal for a pool on here. So obviously you don't want that in your natural water bodies because it's not healthy for the ecosystems that live there. So to do this test, we're going to, you either have a bottle like me or you have, those little Band-Aid containers with the scale in the back. So you're just gonna open the top, make sure you have really dry hands, which I don't. I'm gonna put my water sample down to shake one out. So you just shake one out if you have a bottle, take one. Make sure not to touch the little pads, because your like finger oil is going to affect the little chemicals on there. And then we dip the little test strip for only 2 seconds in the water. So 1, 2, take it out. If you leave it in longer, the chemicals are going to leach and you're going to have all sorts of strange colors on there. We want to wait 20 seconds before we take our measurement. Does anyone know how to read these? Yeah, that's it. So it's like a sliding scale. So for those of you who don't know, you want to align your test strip vertically, and you start at the bottom, and you want to read one at a time. So let's say for chlorine, I'm looking at the top one, and I slowly move my chlorine little pad until I find the one that matches for it, and then I move on to the second one, which is pH, and so forth. So I'm going to turn around to be able to do my measurements. So this is great that you guys are in pairs, because this is a color test, which means that a lot of the times we see and we interpret colors differently. So I suggest you ask your friend what they see as a color, and try to agree on a number. And if the value you see falls between 2 points on the scale, so let's say my pH is between a 6.8 and a 7.2, then you can write down that it's 7. I'm just going to give everyone a second to...
And this one.
So you have one more notepad like this?
For this one?
One more notepad? You can
For
just-
which one?
Oh, you guys don't
The
have
second
one?
one.
Oh,
Yeah.
sorry.
This one?
7.8.
This one, the 80, right?
Yeah.
Last one.
I would say it's 8.2.
Because it's not like dark.
Yeah.
120? Between 80 and 120.
So it's 150.
When you guys are done writing down your results, if you want to share them with us, that'd be great, so we can see what everyone gets.
What's the name of this one?
The conductivity.
Conductivity?
Yeah.
That
Done. Do you want to say your results? Go for it.
Chlorine.
120.
Yeah.
0.25.
0.25. Wait, I have to repeat it for the folks online, so just one at a time.
pH we have 8.
0.2.
For
Alkalinity.
yes, we have 100, and for hardness 150.
Okay, so just to repeat that for the folks online. So pH was 8, right?
8.2.
8.2. Alkalinity you had, remind me? Al-
100.
100, and total hardness 50?
150.
150. Okay, perfect. Did you want to go? Because I think you're the only team that has the other buckets, so I'd love to see if your results are different.
Total chlorine, I got 0 parts per million.
So 0 for chlorine,
Yeah. And pH is 7.8.
7.8 for pH,
And alkalinity is 120 ppm.
120 for alkalinity, and for hardness?
Total hardness is 100 parts per million.
100. So we can see the results are slightly different from one sample to the other. So already that we saw with the conductivity it's different, so just from one place to the other, and me kind of shaking the ground might have affected the results a little bit. Does anyone have anything very different? I don't think we need to say things unless it's all similar. No? Everyone got similar things? Okay, perfect. So we did test some things that we didn't talk about too much. So when I'm talking about pH, can someone explain to me a little bit what we're measuring or why it's important? What's the scale of pH?
0 to 14.
Yeah, 0 to 14, right? And so neutral is right in the middle at 7. And does anyone know what an ideal number is usually, or like a range, sorry, for water bodies when you're measuring? Yeah, oh, sorry, in the back there? Around 8. So yeah, I would say that's like, in a lot of cases, the slightly upper limit, but you can also go as low as 6. So we usually say between 6 to 8 for most water bodies, but different water bodies will have different pHs. So ponds often have lower pHs, and if you ever see a water body that has like really dark water, then often it's quite acidic, so it's going to have a lower pH, and that's totally normal. So that's why it's important to go and test the water regularly, so that you get to know the water body and you know what its normal pH is, so that if there is ever a drastic change, then you can try to understand why. So alkalinity in this case, we measured it as well, and it kind of acts as a shield to changes in pH. So a high alkalinity isn't necessarily a sign that the water is unhealthy. It means that it's gonna be able to withstand more pressures without the pH changing drastically. And what about hardness? Can someone tell me in hardness what we measure, or examples of what might affect hardness in water? No? Okay, so hardness is quite connected to conductivity. It just measures different ions. And for the viewers at home, if you have well water, then a lot of the times you might be aware that your water is hard, and you might need a water softener at home. So for you guys as well, that's usually how people know it. So hard water, you feel it on your hands. It's a little bit like salt water, and it's a little bit like salt water, yes. And soft water feels almost a little bit soapy when it's too soft. The difference between the two. So that's it for this. I'm going to show you one last test, and mostly for the viewers at home and for you to understand how to do it, but we're going to go do it by the water after. So I'm going to show this one last one, then it'll be question period. Okay, so the last test we're going to do here before taking questions and then going to the water is a dissolved oxygen test. I didn't put a kit on your table, but I'll give you one when we go to the water later. So this one's a little bit trickier, so that's why I want to do the demo before we go down. Sorry, there's a wasp. I get really bad allergic reactions, so hopefully I don't get stung. So this is another color comparison chart. So we have it just here, and we're going to break a little glass ampoule in water to be able to take a reading. The reason why we're not doing this test here is that Yannick and I took these buckets of water already like an hour ago, and they've been sitting here, and there's already some mixing happening with the air and oxygen going into the water. So if we took measurements here, then our measurements would be very high. So when you do this test, you want to do it really quickly. You want to take your water sample with a special little cup, and do the whole test in about 20 seconds. So it can seem daunting, but you'll see it's not so bad. I'll show you how to do it slowly right now, and then we can try to go do it quickly by the water after. So we have a box with glass ampoules in there, and you might not be able to see it from where you are, but online you might be able to. There's a little white line at the tip which indicates a weak point in the glass, and that's where we're going to break the tip of the ampoule. So usually I'd be taking a fresh water sample, but I'm just going to be taking my sample, so I'll pour it in the cup. You don't need to fill it up that much. I'm sorry, I keep bending down here. I'm not disappearing, I'm just putting my things down. And at the bottom there's little ridges that are like half moon ridges, so you want to put the tip in one of the ridges on the side, and then you just do a lever motion. So I'm going to push the ampoule on the side. I'm not pushing down, I'm pushing on the side, and it doesn't take much strength. There you go, I broke it, and it absorbed the water, and I'm going to let the little bubble invert up and down twice so that there's good mixing, and it's starting to change colors. And there's a 2-minute timer that's in the little kit, so we have to wait 2 minutes until we can take our measurement, but you can see mine's already getting pretty dark because my sample has been there for a while. So I'm just going to put this down. I have the little glass tip in there, so I don't want it to go in the grass. And let's say I had waited my 2 minutes, but I haven't, don't tell anyone. Then it's the same principle as the test strips. You're just going to slowly bring it until you find a color that matches. I can't see what I'm doing, but if you find a color that's in between two values, then you can write the one that's in between the two, no problem. So this is one that you have to look a little funny when you do. So we usually say, like, try to move around and make sure that the sun doesn't impact like how you see the colors, because it's glass, so it goes through, and it's going to impact how you see it. But you want to take off your hat, your sunglasses, because it's a color test, so you don't want that to affect the results you see. And always check with a friend what they see. So I get about a reading of 10 milligrams per liter right now here, which is pretty high, but it's also in a way normal for colder water bodies. It's a healthy number to support fish, but we'll go see if we get a different number when we get a fresh sample by the water after. So that's it for the demo portion, and if there's any questions, then now's a good time before we go. Yeah?
So what's the science behind that color?
So the science behind the color, it's an indigo dye that reacts with the dissolved oxygen in the water. It's as simple as that. So when the indigo dye is in contact with it, depending on how much there is, it's going to change color.
Good.
Yeah. Any other questions?
So most probably scientists used this method or the YSI meter.
Yes. So there's this method, which is a color method. There's also different color methods, and like you mentioned, there is the YSI probe, which for those of you, I think you're all familiar here, but maybe online you're not familiar with it. It's like a big electronic probe that is used by scientists to go and test the water, but they are prohibitively expensive for the average person to own. So this is the more affordable version that most people can use and understand. Yeah. Any other questions or comments? No? Okay. I think we're done for the demo portion.
Okay, perfect. I'll close it up then. All right, thanks everyone for joining us tonight. This workshop, as well as all of our other Great River Rapport workshops, will be posted on the Great River Rapport website at riverreport.ca/workshops. This will also be posted to the Facebook event page in whole. And of course, we'd invite you to check out the Water Rangers website, which we will be posting in the description of this workshop. So thanks again for joining us, and we will be posting the remainder of our upcoming workshops on the website. Thanks.